Hello class, welcome to a new video. So in this video, we are going to consider some problems which are based on interpolation. Okay, we have learned about the different interpolation formulas. So now let us see some numerical examples, some numerical problems which we have to use these formulas, these interpolation formulas. Okay. So this one question, it is given like this. Suppose your x values are given as 12, 16, 20, 12, 16, 20, 24. And then your corresponding fx values are given by 1, 5, 10, and 17. Okay. Suppose these are your values and you are required to find, you have to find the value of f14. That means you have to find the value of y when x is equal to 14. Okay. So we see here that this 14, so you check these values of x's and see where does 14 lie. So 14 lies between this 12 and 16. It lies somewhere between here. So since it lies in the beginning of the series of the x values, so we have to use what? We have to use Newton's forward interpolation. Okay, we have to use Newton's forward interpolation formula. And another thing is, here how many values of x's are there? There are 1, 2, 3, and 4. So that means you have to write the formula up till delta 4 minus 1. That means up till delta 3. So you have to write the formula of Newton's forward interpolation up till the term delta 3. Okay, so what will be Newton's forward interpolation formula? It will be y equal fx, which is equal to y naught plus u delta y naught plus u into u minus 1 by 2 factorial delta square y naught plus u minus 1 u minus 2 divided by 3 factorial into delta 3 y naught. So your formula ends up till here because your number of x values are 1, 2, 3, 4. So first, let us find what is u. So u is equal to x minus x naught divided by h. Okay, so x is 14 because we have to find f14. Then x naught is the first value of x. So if you check again from the question, the first value of x or the first argument is 12. And h, the interval of differencing. So you just subtract 16 minus 12, it will be 2. Will be 4. Then 20 minus 16 will be 4. 24 minus 20 will be 4. So your interval of differencing will be 4. So that means your u, it will be 2 by 4, which is equal to 0.5. So we have found the value of u. Now let us find these different values of delta y naught, delta square y naught. So how do we do this? Is we have to use the difference table. I hope you still remember what is the difference table. So let us construct the difference table. I hope you still remember how to construct the difference table. So first you have your x values. Then you have your y values, y equal fx. So you write them down. X, it takes the value 12, 16, 20, and 24. And your corresponding y values are 1 and then 5, and then 10 and 17. Okay, so how many columns do you need here? You need delta y, you need delta square y, and you need delta cube y. So you'll have till this many columns. So first you have to subtract 5 minus 1, which will be how much? It'll be 4. Next you have to subtract. Next you have to subtract 10 minus 5, which will be 5. Then 17 minus 10, which will be 7. Then you proceed in this way. 5 minus 4 will be 1. 7 minus 5 will be 2. Okay. And the last term will be 2 minus 1 will be 1. So you have constructed the difference table. So now remember, this first term will be your y0. We need the value of y0, so this will be your y0. Then this first term will be your delta y0. This next term will be your delta square y0. And finally, this last term will be your delta cube y0. So we have found the values of all the terms required in the formula. So you just have to replace these values in the formula. Okay, so therefore your y, which is equal to f14, this will be equal to y0, which is 1. Then your u is 0.5. Then delta y0 is 4. Then plus u 0.5 into 0.5 minus 1 divided by 2 factorial into delta y0 into delta square y0, which is 1. Then your last term will be 0.5 into 0.5 minus 1, 0.5 minus 2 divided by 3 factorial, and then into delta cube y0 is also 1. So I have replaced all the terms. So you just need to use your scientific calculator to calculate these things. You'd have to do it very carefully. Okay, and then after calculation you will find that your value of y, or f14, will be 2.9375. So this is the required value. This is the required value of your missing of your f14. Okay, and in order to check whether this value is correct or not, you check the corresponding values. Remember, the x values are given as what? 12, 16, and then 20, and then 24. And your corresponding fx values are given as 1, 5, 10, and 17. So f14, the value of f14 should lie between 1 and 5. So this 2.9375, it lies between 1 and 5. So hence your calculation is correct. Okay, so you just have to check the steps properly, use a proper scientific calculator, and this is how you solve the problem. Okay, so let's move on to another problem, which is not very direct. Okay, suppose you have the following data. Suppose these are your marks and number of students. Marks and number of students. And your mark, suppose this here you have less than 20, and the next is not 20, less than 30, and then you have 30 to 40, and then you have 40 to 50, 50 to 60, 60 to 70, 70 to 80. Okay, and your corresponding number of students will be 10, 31, 42, 51, 35, and 31. Okay, suppose these are is the question that you're given, and then from this following data you are to estimate the number of students who got less than 45 marks. So you have to estimate number of students who got marks less than 45. Okay, less than 45 marks. So how do you approach to solve this problem? First, you have to balance this out, this given data. Okay, you have to prepare in order to solve this, you have to prepare a cumulative frequency table. Okay, so you write down the marks again. You write only the lower limits. Okay, suppose this is your marks less than x. Okay, marks less than you denote by x, and then number of students you denote by fx. So you write down first only the lower limits: 30, 40, 50, 60, 70, 80. So you have to create the cumulative frequency table. The first frequency will remain the same. The first cumulative frequency will remain the same. Then the next you have to add with the next frequency, then you'll get 41. Then 41 plus the next frequency plus 42, it'll become 83. Then 83 plus the next frequency, which is 51, this will be 134. Then 134 plus 35, this will be equal to 169. And then finally 169 plus the next frequency 31, this will be 200. So this last frequency, you can check that it is equal to the sum of all those fx values, number of students. Okay, all those number of students, if you add, then you should get 200. So this is your frequency table, and then from here you have to use Newton's forward interpolation, because you have to check marks which is less than 45. So 45 lies between 40 and 50. Okay, 45 lies somewhere here, and this is the beginning, towards the beginning of the series. So hence you have to use Newton's forward interpolation. And how many the formula will end till where? You have 6 values, so the formula will end till delta 6 minus 1, which is equal to delta 5. So your formula will be what? Newton's forward interpolation formula will be given by y equal fx equal y naught plus, y naught plus u delta y naught plus u into u minus 1 by 2 factorial delta square y naught plus u into u minus 1 u minus 2 by 3 factorial delta 3 y naught plus u into u minus 1, u minus 2, u minus 3 divided by 4 factorial into delta 4 y naught, and finally u into u minus 1, u minus 2, u minus 3, u minus 4 divided by 5 factorial into delta 5 y naught. Okay, so this is your Newton's forward interpolation formula. When you have 6 values, it'll end up till here. Okay, so now you have to find out each of these values. First and foremost, what will be your u? U is x minus x naught by h, and x is your it will be 45. First argument will be 30, and then the interval of differencing, you can find out it is 10. Okay, so this becomes 15 by 10, which is equal to 1.5. So now you have to make the difference table. You have to construct the difference table. So first you have your x values, then you have your y values, then the number of columns will be delta y naught, not delta y naught, delta y, delta square y, delta cube y, delta 4y, and delta 5y. So you'll have this many number of columns based on the deltas which you have to find. Okay, so you write down your x values. So 30, then 40, 50, 60, 70, 80. And your corresponding y values will be 10, 41, 83, 134, 169, 200. Okay, so now you approach in the same way. You find out. So here 41 minus 10 will be what? It'll be 31. Then 83 minus 41 will be 42. Then, so you fill up all these values. You will get, if you do the calculation by yourself, you will get these values, 35. And then 200 minus 169 will be 31 again. Then you continue in this way. 42 minus 31 will be 11. 51 minus 42 will be 9. 35 minus 51 will be minus 16. And 31 minus 35 will be minus 4. 9 minus 11 will be minus 2. Minus 16 minus 9 will be minus 25. Minus 4 plus 16 will be 12. And then minus 25 plus 2 will be minus 23. And then 12 plus 25 will be 37. And then finally 37 plus 23 will be 60. So you take care of the signs properly, and you will get the difference table like this. So this 10 will be your y naught, 31 will be your delta y naught, 11 will be your delta square y naught, minus 2 will be your delta 3 y naught, minus 23 will be your delta 4 y naught, and then finally 60 will be delta 5 y naught. Okay, so this is your difference table. And then now you have all the values. You have the value of u, you have the value of these deltas. So you just substitute in that formula and you do the calculation by yourself, because this is all just calculation, and you're supposed to get y equal, not y, you're supposed to get F45 to be equal to 59.508, and then this you just round up, it will be 60. So hence 60 is the required number of students who gets less than 45 marks. Okay, so this is how you do these calculations, and then you practice again and try to understand clearly. In the next video, I will show you some problems where we have to use the other interpolation formulas.